more test. The problem is I think the marking period might end before we get to it. So
It will end before we get to it.
because the marking period ends next Friday, right, or
So
something.
there's no, well, that means I settled.
And you said the fourth mark.
Well, next Friday.
I know. So I don't know. We'll see. If we can get through
Make the
everything,
test really short.
We're off.
then I'll give a test next Friday.
Group test.
No, you won't.
But we'll see. But we're on schedule to finish before spring break. What I'll do is over spring break, I will be giving you a packet.
Oh, you kidding me?
No,
No, you won't.
yes, it will.
Great.
It'll be your. I don't know. We'll see. I guess yes.
No.
Yes. Looks like I'm
Most
failing.
probably, definitely, yes.
It'll be your first review thing, and then when you get back for 2 days, you start to go over it, and then you'll leave for Disney, and then you'll get back, and we'll have like a week and a half or so, 2 weeks to finish review.
What's the
So
date
what
of
are
the
we
test?
doing if we're not really
May 9th or 7th.
And then after that, what do we do?
No, it's not the week before.
When's the practice?
And I want
that
to
we
worry
have?
The week before, so like May 2nd, I have to pick a date.
Wait, then I want to worry.
And now your senior service day is May 1st, so it's going to be a real big pain.
Wait, no, that's
Are you going to email?
Do you have to go on senior service day?
It is good.
Because it doesn't.
No, it's optional.
You get a whole day of school off.
Yeah.
Then you
Yeah,
can.
we
I wouldn't go to
Well,
I will.
Plus, we got barbecue. All of those out.
Oh, wait, no.
don't want to work.
I remember from practicing the April even though I'm not taking it.
But I want to do that.
Jam. I don't know.
Mike's mad.
Okay. So we've kind of covered half of the series section or chapter, and the first half just deals with like writing them, understanding what they're about, looking at geometric series, knowing what a geometric series converges to. And we talked a little bit about an interval of convergence and that like series converge on certain intervals, some converge everywhere. Do you get what that means, converge? There's like,
It's
converge means like, it can have two meanings. One means like as you go to infinity, your series adds up to a number that you can quantify. The other way of thinking about it is your series and your function look exactly the same on some interval. So if an interval of convergence is -1 to 1, that means the series look exactly identical from -1 to 1 if I could have all the terms of the series. And if you go beyond -1 to 1, they're not going to match. There's no guarantee for how they match. So there's those two ways of thinking about convergence. This next part is really tedious, as if the first part wasn't tedious itself. But there's all these tests to determine whether a series converges or not.
Yep.
And we've already done one. The test we did was the geometric series, because we knew in the geometric series, what did R have to be for it to converge? Less than 1 or bigger than -1, right? Like it had to be between 1 and -1. And if it wasn't, then the series didn't converge, and we didn't find a sum for it because it didn't converge anyway. But that was only geometric. So if the series isn't geometric, there's a whole list of tests. So we're going to do the most important ones and go from there. All right, the first one is called the nth term test. All right, we won't hit all of the tests today. Probably between, what's tomorrow, Thursday? Hopefully between today and tomorrow we hit them all. Friday's the Hunger Games. I think you guys do get back in time, but I'll probably just give some kind of assignment, like, so that you can work on it that day and over the weekend. No, I'll be here. I'm just saying, like, we won't do probably a lesson, because everyone's going to be all hyped up. All right, the nth term test is actually only a test for divergence. And I'm going to have to keep referring to my notes because I've forgotten a lot of them, so I have to like...
If it's testing whether it diverges, doesn't it also test for...
No. The
What?
conclusions that we draw from this test will tell us that it diverges or that it maybe converges. So
point.
It's-
A useless.
It's not useless because it's quick and easy, and if you get that it diverges, you can just stop doing the problem. So it's a little bit useful, and all it just says is this, is if we take the limit as n approaches infinity of the series, if this does not equal 0, then the series definitely diverges. You guys see this?
That's the same as for geometric, right?
It's basically the same for any single series. So the idea is if you look at a series and you just quickly think like what happens as n goes to infinity, if you don't get 0, you can immediately say the series diverges and I'm done. If you do get 0, that's not conclusive enough proof to say that the series will definitely converge. It still could diverge. You just have to go do more tests. So for example, let's do, pardon me. All right. Part of the reason we did that day of like what grows faster is so that you could do some of these problems quickly. If this is my series and I want to use the nth term test, what I'm really doing, if I use that, I'll write this up so that you have everything like kind of neat in your notes. If I want to try to apply the nth term test, I'm going to take the limit as n approaches infinity of whatever the series is. Well, if I look at that limit, I should see that when I plug in infinity top and bottom, I get infinity over infinity. So what would I do? I would do the L'Hopital's rule. So then I'd look at the limit as n approaches infinity. 2 to the n, do you remember what the derivative is?
2 to the n natural log of 2.
2 to the n natural log of 2 times the derivative of n, but that's just 1. And then on the bottom we just have 1. So now if I plug in infinity, what's it going to? Infinity. Does that make sense? But you could have done this more quickly, and when we really start reviewing, you just have to approach the problems as efficiently as possible. That you can see way back here. Like without ever doing L'Hopital's rule, bless you, the reason we talked about what grows faster than what is like to be able to look at this and be like, this top grows a lot faster than that bottom. So because this top grows a lot faster, I can just jump right to the fact that the limit is infinity. If you're not really good at that, that's okay. But like just be intuitive, like which is going faster, 2 to the n. Like that's huge. As I plug in more and more n's, or n plus 1, like that's just like plotting along one at a time, you know what I mean? It's like if you can reduce it, or get it fast, do it fast. So, therefore, because the limit of the series was infinity, and infinity does not equal 0, the series diverges. So yeah, it's kind of a useless test, but at least you can stop a problem right away by just doing it, being like, nope, the limit's not going to be 0, it's going to diverge and you're done. Is that okay? Alright, so the second test I'm going to write up is the geometric one, even though you already know it, that way it's just in your notes. So the second thing is if you find a series and it's geometric, you like hit a home run. You should be excited. Woo!
Baseball.
A little baseball analogy. And you might not even realize it's geometric at first. What's going to be hard about this is you're going to get a series and you have no guidance over which test to pick. So that's what makes it confusing. Right now, we've only done geometric, it's pretty easy, but it's going to start to get a little weird. So my rule of thumb is start with the nth term test. unless you definitely know it's geometric, but if you're unsure, just start with the nth term test and look at it. Let's look at the limit as n approaches infinity of -1/8 to the n. That is 0, right? Because as I plug in n to infinity, the bottom's going to get huge, so the whole fraction gets small. So, therefore, it's inconclusive. So I would say, whatever, it's inconclusive. Okay, I don't know if that is telling me that it diverges or converges. That means it probably converges, but you don't know for sure. And then I'm going to be like, yay, it's geometric. And the way I know that it's geometric is anytime I have something to the end, it's geometric. But if I'm really unsure, I can get the first couple of terms. So if n equals 1, I'm going to have -1/8. And if n equals 2, I'll have -1/8 squared. And if n equals 3, 1/8 to the third, negative. And the way I know it's geometric is there just a consistent multiplier from one term to the next? Yes. My first term is -1/8, there's my a, and then my r is just that multiplier. So what's the multiplier? 1/8. Is that less than 1? Yup.
Maybe.
So therefore, this converges. Okay, because it's less than 1. So we already knew that, but it's just a good to remind you whatever. This same series, there are other tests that will work for it. So you don't always have to use the geometric test, you could use something else, but geometric is going to be the easiest one. Okay, here's where it gets interesting. Third test. It's called the integral test. What's that?
This is what calculates.
I guess, yeah. Okay, so if your series represents a positive, continuous, and decreasing function, I think so. If not, there's some in the desk. Oh. Okay, if it equals a positive, continuous, and decreasing function for all values of n that are bigger than equal to 1. So basically, like wherever the series starts, like at n equals 1, the function that series is representing is positive, continuous, and decreasing. It's got to be, right? Like, well, whatever. If I have a, don't write this, but if I have the series x to the n, that's not a decreasing function, that's increasing. So I'm not even going to look at that, and that's going to diverge because it's going to be so big. But as long as I'm decreasing, the chances are that maybe that's going to converge, that's what I'm going to be looking at. Well, the idea is, the series of a sub n and the integral of a sub n from 1 to infinity either both converge or both diverge. What this is really saying is, check out the integral. Take the function and check out the integral of it. If the integral converges, then the function converges. If the integral diverges, then the function diverges.
Is that an addition sign
And
between?
this,
Yeah.
this is like,
Oh.
the main point in the integral test is to actually introduce you to the p-test. Let me do an example and then we'll get to that. gonna look at that series, and when I first start, I would be like, all right, nth term test first. So the nth term test says, let's just look at the limit of this and see what happens to n. What is the limit? Like, just by intuition, if I have an n squared over an n to the third, what's the limit as n goes to infinity? 0, right? That bottom's going bigger than the top. So since the bottom's going bigger, the limit is 0. So that means it might converge. At least we don't have definitive proof that it diverges. So there we go. It's not geometric. If I plugged in some numbers, I'd see that really clearly, but I don't have like something to the end, so I know it's not geometric. So we're gonna look at the integral of 6n squared over n to the third plus 1. And we're gonna decide whether that converges or not. And what I mean by that is, do I get a number out of this, or do I get infinity out of this? If I get infinity out of this, it diverges. If I get a number out of this, it converges. So here we go. So if I'm going to integrate this, I'm going to rewrite this as the limit as a approaches infinity, have the integral from 1 to a. Okay, just like we did like on the test the other day, blah, blah, blah. What do I use to integrate it?
You look at it and say, this is what it is.
No. So don't worry about the limit part. What do if I have to integrate this, how do I do it?
Substitution.
Substitution. Okay, let's pick the denominator to be u. And therefore du is 3n squared. That's annoying. So if this is 3n squared, I have 6n squared, so I need this to be multiplied by a half. So I need a 2 out front. So I get the limit. Tell me if I go too fast. So, whoops, or mess up. So I have the 2 in front, 1 to a, and I have du over u. Okay so far? So I've got the limit. What's the integral of du over u? The natural log of u. I'm going to go ahead and just replace that right away with n to the third plus 1, evaluated from 1 to a. Remember that it's supposed to be the natural log of the absolute value, just a little thing to throw in there. The closer we get to the test, the more I'm going to start to remind you of some of the old stuff. But the integral is actually the natural log of the absolute value of u. So I put the u back in. So now I'm looking at the limit as a approaches infinity. Plug in a, so 2 times the natural log of a to the third plus 1 minus 2 times the natural log of 0 plus 1. So,
Why is it 0 plus 1?
oh, sorry, I'm talking. 1 plus 1. Here's the thing. This might seem kind of confusing because what does this go to? The natural log of infinity, this is going to be infinity, this is going to be minus 2 ln 2. Once either part of this sum or difference is infinity, the whole thing's infinity. If I wanted to, I could make a fraction out of this because I have natural log subtracted and I could put this on the bottom so that I'm really be looking at like 2 times the natural log of a to the third plus 1 over 2. Do you get that? Okay, since I have subtraction, I could make this division of the natural logs. Or division of the natural log of the division of the whatever. So I can see pretty clearly now that it's going to infinity. But when I have this natural log problem where they're both subtracted and one goes to infinity, the whole thing's going to infinity. So, what does that mean?
The second one goes to infinity and one and it goes to 0. Yeah. Or it approaches negative. Because if you put it in a fraction, it's 0.
Then,
Oh, so,
well,
so it wouldn't exist.
Wait, say that again?
If the second one
one of them would always go
If
to a
the
constant.
second one's infinity, it'd be the question of which one's going faster. Like, you'd have to almost look at like,
But wouldn't one always go to a constant because you always have a
In this case,
number
yes.
to start?
So really the question is going to be, does this go to 0 or does this go to infinity? Because if the first one goes to 0, then the answer is going to be 0 minus this, it'll be negative this. If this one goes to infinity, your whole thing is going to be infinity. You know what I mean? But I'm thinking, because you're never going to have a variable for the second one. It's always going to be a constant. So your question is more just, is this going to 0 or is this going to infinity? And that's going to be what? Because if this were the natural log, I mean, if this turned out to be a fraction, this would be going to 0 and this would be, you know what I mean?
Infinity cubed.
What if this were the natural log of like 1 over a? What would that be going to? 1. Because as a goes to infinity, this goes to 0 and the natural log of 0 is 1. That could happen too, I guess. But anyway, for this one, it goes to infinity. So way back in the beginning, this diverges.
The natural log of 0 is impossible.
Natural log of 0 is impossible.
You're impossible.
Oh shoot! No, why did I say that? Right.
Cause you fail.
No, we don't. No, I'm sorry. Yeah, you're right. That's a dumb thing to say. Yeah.
Jimbo should be on YouTube.
No, I totally messed that up. I was thinking that the natural log of 0 is 1, but it's not. The natural log of 0 is undefined. Then we'd have to go look at other. Yeah, no.
Wait.
Back up the tape. Yeah, don't even go there. I tried to make something up off the top of my head. That was dumb. Bye, you too. I feel. Oh, there's so many people not here.
So we stop.
This leads us to a really big conclusion.
Taboo.
I don't care about that.
That's sweet.
Big conclusion, go.
All right, big conclusion. Ready?
It's being videotaped, so.
Yeah, they can look at it. So this leads us to a big conclusion that you really want to know, and that is the p-test. Leave that. I'm going to leave that here, and I'm going to write the p-test up because we're going to look at that in a second.
Sounding like stats all the time.
What color?
I know.
Kind of sick.
Because the p-test you actually already know.
I know, I play a sport.
Will this take up a lot?
Nope. If I have the integral of 1 over n to the p,
What does this look like?
what?
What does this look like to you? That one problem I have no idea how to do.
We already did this. Yeah. If p is greater than 1, then what happens? Converge. And if p is less than or equal to 1, the integral diverges. The reason why this is important is that integrals and series now can be looked at not as one and the same, but they can be looked at as one and the same when we're talking about convergence or divergence. So the integral test says if I have a series and if I look at its integral, I can tell whether it converges or diverges based on what its integral does. So if I have a series and it has this general form, if p is greater than 1, then the integral converges and so does the series. And if p is less than or equal to 1, the integral diverges and so does the series. So in a problem like this, I didn't actually even have to do all of that work of the integral test because I can think about what does this basically behave like. This basically, if I'm going to like reduce it, this plus 1 is stupid. It's not doing anything to the problem. This plus 1 isn't affecting it at all, and neither is this 6. This basically is behaving like n squared over n to the third, which therefore is basically behaving like 1 over n. Which therefore it diverges, according to the p-test. So the p-test is a shortcut for looking at whether a series converges or diverges when I'm going to use the integral test, and it gets used all the time. If I just take this and I kind of like reduce it, some people just get confused about what you can cancel and what you can't, but it's just a plus 1. Like, think about, as you're going to infinity, does a plus 1 matter? No. Or a times 6 matter? No, it doesn't matter at all. What matters is that n to the second and n to the third. So if I just reduce them up a little bit, I'm really looking at 1 over n. In fact, if I graphed this and I graphed this, they wouldn't look all that different because they behave the same way. they wouldn't look really different at all. So this p-test is huge. It's really a part of the integral test. And it's really, 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 really good to know that if p is greater than 1, the thing converges. And I have a fun note for you.
Fun fact.
Fun fact, are you ready?
You're getting
I'm getting a horse?
Getting it.
What?
Just say
Maybe,
yes.
yes, afterwards.
Would you say I'm making that voice?
No.
No.
Just ignore it.
Shut up. I'm gonna go back and watch the video. This has a special name.
Then
It's called the harmonic series.
Um.
That's not exciting.
Okay, it's called the harmonic series, and it's good to know what the harmonic series is. You'll impress your friends at dinner parties and stuff. That you know that the harmonic series is 1 over n, and it is the most famous divergent series in math
Wow.
because, so it diverges, right? Because my p is 1, so if my p is less than or equal to 1, the series is going to diverge. It's kind of like the biggest, or I'm sorry, the smallest thing that still diverges. It's like the smallest function that still diverges. So even though this function goes down, 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 it still diverges, and it's like the smallest one that does that. It takes, are you ready for this? You're going to be impressed even though you won't admit it. It takes 178,482,301 terms of the series to provide a sum bigger than 20. Isn't that crazy?
what?
But yet it still goes to infinity.
so slow.
So slowly. I'll say that again.
You did that all yourself?
What?
You did all those terms yourself?
No. So get a series. A series is that we're adding up. So like this harmonic series is, we start with 1, plus 1/2, plus 1/3, plus 1/4, plus 1/5, plus 1/6, plus 1/7, blah, 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 blah. So like we get to 2 pretty fast, like 1, and then 1/2, 1/3, 1/4, like there, we're over 2, right? And then we're gonna, be over 3, over 4, whatever. 178 million terms plus some. To get to a sum above the number 20. So think about how many terms it must take
Dude, say that.
to get to the sum of like 100. And the thing's infinite.
You
It doesn't
calculated
converge.
again.
I will not. It doesn't converge. It goes to infinity. So like, holy crap.
All right.
How do they ever figure that out? If it takes 178 million terms to get to 20, you would think that's slow growing enough to
It'd be like,
converge.
Sad, sad old man.
It's crazy. That's all I got. Alright, we'll do another test